Well, hello, wonderful students. I wanted to make you this video. Once I had this assigned and some students took it, it would gave me like an error when I tried to edit it. So I'm really sorry, but let's take a look at it because if you noticed, some of you might be frustrated because you're getting them wrong. You're like, I don't understand. We didn't talk about this. It's not in the lesson. What in the world? My mistake when I created these a week ago, 2 weeks ago, to put in the course. Well, anyway, I made mistakes, so I apologize. This one you guys should know and try again, paying attention to the phrases. Not more than, at least, does not exceed. What are those symbols, okay? And then just try your best. This one, however, is a quadratic inequality, something that we're not going to talk about until Unit 3. And then down here is dealing with radical solutions, and we won't deal with that until Unit 2. So I truly apologize. Let's go ahead and use this, and we'll talk about this bottom one first, okay? This question 2, or if it I don't know if it changes the order on you guys. The second part is asking what is the solution for x squared plus 4 less than or equal to 0? In my mind, when I saw this, I was like, ooh, that's a good question. We could just kind of think about it by inspection, meaning, okay, I know x squared. I know what this function is. I've seen it before. It's an opening parabola. It opens upward. Well, I know if I square it, if I have a -3, let's say, times a -3, well, that's going to be a +9. And if I have a regular 3 times a regular 3, +3, right? It's going to be a +9. So this right here will always be positive. If it's always positive, that means when we add, it could be 0. It could be 0 or positive. So yeah, it does hit right there on the axes. 0 plus 4, well, that's less than or equal to 0. It's still not true. This will never be negative, so no solution. Now, algebraically, which is always important, and I solved the top one wrong in class. Well, I solved it correctly, but I forgot the check step. We always have to check when it comes to inequalities and radicals because we now have, anyway, it'll make sense in a second. So algebraically, we still do the same steps that we would right here, right? We're still trying to get x by itself, so we'd end up with x squared is less than or equal to -4. So this step is very familiar. This step maybe we don't remember. Well, we want to undo this radical. So let's undo the radical. So I take the square root to get rid, we want to undo the square. We use the radical to do that. So we take the square root of both sides. So over here, we end up with x less than or equal to, and often we'll talk about this plus or minus in different situations. We do plus or minus the square root of -4. Wait a minute. The square root of -4, well, that creates what we call an imaginary number. We have I, the imaginary number, set equal to, we define it, it equals the square root of -1. So this is actually going to imply plus or minus 2i. That's actually, that's a solution in imaginary numbers, but we're not going to talk about that this unit. So I'm sorry. I just saw these questions and my teacher brains, ooh, that's an interesting one. And that's not the point, not just interesting questions. We slowly build up, use this to review. So, all right, there we go. There's my apology for that part. And up here, in class, I solved it in the morning class. I haven't seen those of you, and I'll see you in a few minutes. You would solve this very similarly to when you solve a quadratic equation. So this is a quadratic inequality, and the only difference is that equal sign. So I leave it there. I've seen some help videos where they don't. They change it to equal and then go from there. But really, it's okay. We've got to get comfortable with that inequality being there. What you do to one side, you do to the other, right? So I'm going to take away x from both sides, and I'm going to take away 5 from both sides. You can do this in multiple steps if you want, if it helps your brain. I'm just going to do it in one step. So we'll have x minus x on the right-hand side, or my camera's reversed. We'll have plus 5 minus 5 on the right, this side. And so we'll be left with 0. Okay, we have x squared. We got to leave that. Minus x, there's no other like terms, so we just put minus x. That came again from this x. We subtracted from both sides. Negative 1 minus 5, that becomes minus 6. Factoring strategies. If you remember them, fantastic. If you like the quadratic equation, fantastic. If you want to graph, fantastic. Lots of different ways to solve. I'm going to talk about the algebraic method right here because this is the one that was tripping me up. It was a trip step. You can copy paste this whole thing into Desmos and you'll see some dotted lines, some shading that will help you decide. So again, I'm a big fan of technology. Really, I am. So main reason is it's not going anywhere and we need to get comfortable with it and we need to do thinking deeper than solving. Okay, x has no coefficient, the x squared term, so we know we can split it into parentheses x and x because when we refoil, we'll get x squared. We have a negative and a negative, so I know that my signs are going to be, one is going to be a negative and the other is going to be a positive because if you remember the foiling steps, that whatever goes here is going to be multiplied by here. So if they were both positive, this would be a positive. If they were both negative, this would be a negative. So we know we have to have at least a negative and a positive. Again, we'll talk more about this when we get to Unit 3. Next, we look at the 6, and we need the middle term to add up to negative 1. So the factors of 6 are 1 and 6 and 2 and 3. That's it. We could try, because this is negative, we know the larger number has to be with this negative sign because when we combine them, we need a more negative number than the positive one. So 3 or 5 have to go here and 2 and 1 have to go there. Otherwise, when we redistribute, when we FOIL, we won't get the right equation. 5 plus 1 is negative 4, negative 5. Negative 5 plus positive 1 is negative 4. That's not going to work, but negative 3 plus 2 would end up getting us negative 1. All right, at this point, we're essentially done. Algebraically, let us take a look at this positive 2. Oh, hold on. This will be, let's keep going. So we know that either to make this set equal to 0 or greater than 0, we will have, I see where now it becomes useful. So let's pause right here. And yes, let's set this equal to 0. So we know we'll have x minus 3 is equal to 0, which means x equals 3. So we'll write that there. I see how this is helpful. I see this algebraic technique. This is what I was missing. Okay, we set it equal to 0 now. And we'll subtract 2 from both sides, right? So we have an x equal to negative 2. Okay. This step right here is what helps us solve algebraically without using technology. Our classmates shared, and in the videos we watched in class or will watch in class, it talks about picking a point and checking your inequality. That's a very common strategy and one that I forget, you may forget, but we should get comfortable trying to use. And this will help us. So first, I know it's going to be an open circle. We got to check these points though to figure out what's going on. So I want to check negative 3. We can check 0 if you want. And 4. We can check some of these numbers to help us decide how we're going to shade. Again, if you graph it, if you graph this one, you'll get a parabola, and then you can see where is the parabola greater than 0. So you can try it graphically, but this is algebraically. Okay, got to keep going. We got only a minute or so left so I can get to you guys in class. Let's try 4, or let's try 3. Let's just plug in 3. We get 0, so let's try 4. So I'm going to put 4 in and see what happens. So we have 4 minus 3 times 4 plus 2, which will be 1 times 6. Okay, it should equal 6. Are we satisfied? 1 times 6. So that is greater than 0, so we're good. I like the 4. We can try 0 real quick. We'll get negative 3. See? See, it just frustrates me. What is going on? Because that would be negative. Oh, no, we're good. My mental math failed me. All right, 1 minute left. 0 minus 3. It was my mental math, trying to look ahead, trying to work too fast. Everybody, I recommend just following the steps sometimes. Okay, good. So now I plugged in 0 for x. I get negative 3 times 2, which equals negative 6. And remember, we're checking for, is that greater than 0? No. So this is not a solution. So right there, we kind of have a strong hint then that we need to shade this way. But let's check it. Let's try negative 3. So finally, we'll have negative 3 minus 3, ooh, crazy 3, negative 3 plus 2. This becomes negative 6. This becomes negative 1. So this whole thing becomes positive 6, which is indeed greater than 0, letting us know we need values less than negative 2. All right, thanks for watching. I'm going to come see you in class. Great job. The only other question that isn't for today's content, but will be for tomorrow's content, is this one. I believe in you. Try it. You can do it. We will talk about it tomorrow, though. So if you miss it today, that's all right.